Okay, let's talk about voltage drop. Let's try to figure out exactly what voltage drop is. It's very important. You need to understand it. And reading voltage drop is not the same as reading voltage. There's a difference in the way you hook the meter up and a difference in the expectations. Okay? Voltage drops only happen when current flows. If current's flowing, there will be a voltage drop, good or bad. All right, let's look at a quick and dirty circuit here. Two resistors, 50 ohms each, 12 volts, 1245 applied. Let's turn the switch on. All right, so I got about 12.45 coming into the board, which means we're going to have about 12.45 coming into the first resistor. Well, the two resistors are the same. They're both 50 ohms. So if we read the voltage coming into the first resistor, it's going to be our 1245, but the voltage coming out of the first resistor is going to be about half because the two resistors are the same and they drop the same amount. When we come out on ground, there shouldn't be anything more than millivolts. So the first resistor drops about 6.2. The second resistor drops about 6.23, and you add those two up and they equal 12, which means there's nothing left over. All the voltage drops have to add up to equal source voltage. In other words, all the voltage has to go away. You can't not have it go away. It has to go away. Okay? So if all the voltage has to go away from positive post to negative post of the battery, if you think about it as a circle, which is why it's called a circuit, under normal conditions, the only components that should actually use energy, that should drop voltage, that should do something, are the components that do something. So anything that actually does something and turns electricity or voltage or energy into something else that's all that should be using voltage. So a horn or a light or a solenoid, the components that actually do things should use energy and nothing else should. If anything other than a load component uses energy, it's wrong. Okay? Now, you can say a resistor and a speed control, but that's slightly different, but that's not a problem. That's normal. But wires, connections, and switches, or anything else in the circuit other than the load uses voltage, it's a problem. And if one of these uses voltage, then what's happening is there won't be enough energy left over to operate the thing that's really supposed to be doing something. So headlights are dim, motors run slowly. That's what the result is if I added resistance in the circuit. Okay, now let's look at another quick and dirty circuit here. We'll put the two resistors in. Okay, but let's look at what happens in the real world. In the real world, we don't have this nice, neat little scenario, okay? In the real world, you've got a bulb in a socket, and you pull the bulb out in order to make the test, which is what the manufacturer tells you. This could be an ECM. This could be ECM power. It doesn't matter. The problem is, as soon as you pull the bulb out, you've opened the circuit. Well, how much current's flowing? None. And what was the requirement for a voltage drop? You had to have current flow, okay? So in the top circuit, the reason that there's a 2-volt drop there is because the circuit's closed and complete and current's flowing. The bulbs are getting hot. The resistors are getting hot, okay? So the top circuit's working, bottom circuit's not. Well, the reality is that if the bottom circuit's not working because you've opened the circuit to take the reading, then the 1245 is going to show up and that's going to throw you off. You're going to go, hey, I got 1245. I must need a new bulb, or I must need an ECM, or I must need a new coil, or I must need a new clutch, or I must need a new motor. But there will be no voltage drops if current isn't flowing, right? So as soon as you open the circuit to make your test, boom, you're screwed. So this 50 ohm resistor really isn't a 50 ohm resistor. Neither is that one. The truth is that if current's not flowing, you're not going to see what you need to see. So the critical reality of a voltage drop is, to see it, you must have current flowing. Okay? Now, watch what happens here. If I jump across these two resistors and take them out of the circuit, then the bulb works. All right, and we've already done this math, but let me show you again. All right, we got 1246 coming in, 681 coming out, and about a volt coming to the bulb. Well, the bulb is not really working very well. So That's pretty obvious. And the reason it's not is because by the time you get to the bulb, there's only a volt left. Okay? Well, imagine what would happen if this was an ECM, all right? It can't work because the resistance is in the way. But only when current is flowing. Because now look what happens. Oh, there's that negative sign again. Cannot have a negative sign when you use these load pro leads. You have to have a positive number here. So we read full system voltage, but wait a minute. There's two resistors in the way. But look what happens when we load the circuit. We drop voltage. We get an instantaneous voltage drop because this resistor and this resistor aren't doing anything until the current flows, so the voltage is normal. We're just reading the battery voltage right now. Push the button, circuit turns on, voltage drops. We know we have a problem in the circuit. Okay? So it's dropping from 1281 to about 1.3. Well, look, there's 000 drop across this one because it's not doing anything until you put the bulb in and the voltage drop comes back. But notice the bulb isn't lighting up, but it's still working. This is where people get so goofed up. The component's actually working, but not really, but just not much. And that's where the problem lies. The voltage is there until you plug it back in, and then the voltage goes away. In this case, there's a volt coming to the bulb, and you notice the bulb's not on. But as soon as we pull the bulb out, it goes back to full system voltage. This is where the manufacturer's instructions fail you, because it tells you if you have voltage, go to the next step. And when you get to the end, changing the part doesn't fix the problem. These leads make that problem go away.